So here's some actual data. It's not hard data. I don't really know how far I coast. But starting at, don't know how fast I come off the wall either, but starting at 2 meters per second, I coast 3 meters before I can no longer tell I'm moving, okay? Now this is in water, pushing off of the wall. These are just rough estimates. I think that this might be a little high, this might be a little low. In any case, what's the drag coefficient in my body, my mass? 75 kilograms, in case that's relevant, and it certainly is because mass comes into the equation. So we understand that the faster you move through water, the greater the drag. And there are two basic proportionalities that we start with. Basically, drag is pretty much never going to be less than proportional to the velocity, okay? It's not going to be proportional any power of the velocity less than 1, because you got to move the water out of the way and the physics of it and so forth that I'm not going to get into, but we can talk about that in physics, okay? The net force then could be of magnitude gamma v squared, okay? Now this could be plus or minus gamma v squared, depending on the direction of v. If v's in the positive direction, then this is going to be negative. If v was in the negative direction, this would be positive. We could get around that by saying negative gamma v squared multiplied by v over its absolute value. Then it will always be in the direction opposite v. So our equations are very simple, much simpler than the equations we saw about a week ago, where we talked about free fall and we had weight tacked on here. Complicates the equations quite a bit. So we want to do the simplest possible equations right now, just so we get used to applying initial conditions and so forth, okay? So the first equation becomes this with this solution. That's very straightforward. Okay, second equation becomes this with this solution, and I wrote it down and messed it up. First I had a negative here, and then I forgot to take the reciprocal because I didn't do it right in my head. Okay. But anyhow, so I wrote it out and found out, because something wasn't right, found out what I did. Okay, dv over v squared, integrate that, you get negative 1 over v. Integrate negative gamma over m dt, you get negative gamma over mt plus c. So v is the reciprocal of gamma over mt plus c. Okay? Now we have a negative here and a negative here, and of course the c absorbs the negative. Now, how do we put these conditions into this one and into this one, and what do we conclude? And remember, what we're trying to do is figure out what the drag coefficient is in each case.